I was going to just write up a solution for this one, but I actually am going to bring it up because it's worth considering our problem solving skills for this particular problem. So if you are doing this question and you just need a hint to move on, consider pausing this the moment I get to a spot where you can progress. So the problem is a particle moves in a straight line with a velocity function v of t equals cosine t. Now, this just gives us the velocity here is going to follow a cosine function. So if I was going to graph this cosine function, I don't have much room here. I'm just going to consider this as a rough sketch here. This cosine function would start at 1 and then it would go down and turn around and it would oscillate like this. So we would see that at values of t equal to pi on 2 and every k pi after that, so let's just write plus k pi, we would see this particle equals 0. It has a velocity of 0. Now, from what we know of kinematics already, before even doing any integration, that should be a big hint here that we're going to have a max or a min at these points. Okay, so this is a big hint with show that the particle oscillates between these points. We should be already intuitively knowing that we're going to see every pi, we're going to have a max or a min, and every 2 pi, just purely based on this, every 2 pi we would be back to the same value again. Now, straight off the bat here, we're going to do the integral because show that the particle oscillates between 2 points means we want to show that it goes up and down and its displacement. This is talking about displacement here. So this is asking, show that s of t also is a periodic function. Periodic function. So to find s of t, we do the integral of the velocity, which is cosine t. So integral of cosine, let's move that over actually. So there we go, s of t equals cosine t dt. And so from this we should get that it equals sine t, all right, plus c, where c is a real number. So what this now means is our displacement here, if I was to graph it, so s of t would have this graph of, I'm going to draw this one a little bit more accurately because it's displacement. It would have this value y equals c here. Now you notice I'm not writing y equals 0 because if c ends up being 10, this just means this particle oscillates around 10. So it'll go up, sine goes up by 1 and then it goes. So the sine function starts at 0, okay, and then at pi on 2 it's at a max, so it'll be 1 unit bigger, so this will be c plus 1, and then here it will be back at pi, it'll be back at 0, and then down here it will be, this is at 3 pi on 2, and then over here it will be 2 pi and it's back at 0. So we will see this sort of function here, forgive my rough sketch, it's actually come out reasonably well. So this is our value. Now our min here is obviously going to be c minus 1. So this should be a refresher from our value there. And so we would say here, therefore, the particle oscillates from c plus 1 to c minus 1. All right, now I haven't actually looked at what the solution is for this one. So 5C.2, let's see what they've said. Question 5, they don't bother there. They've just jumped between them. So that's A missing there. But pretty well you can see from here, like if we look at our sine diagram or we're looking at our max and our min, as I sort of said over here, so you got to remember these values here, if we were doing a sine diagram for the velocity, which we're meant to do, this value here would have been at pi on 2, and this would have been here at 3 pi on 2. And if we look at our graph of the sine function, these values would correspond with the max and the min. So these values here will be our max and min. And so find the distance between these values. So distance between 2 points is, it's going to be our max minus our min to show us the distance it oscillates, and that's going to be S of pi on 2 minus S pi on 3, sorry, not pi on 3, 3 pi on 2, which is going to equal, this will equal C plus 1 is our max, and then minus C minus 1. So let's put them in. That's our max, take our min. So the C's are going to cancel. We're going to have 1 plus 1, which equals 2. Now our unit here is key meters per second, which means our displacement is in meters. So it is going to be a displacement of 2 meters. Thanks.